let's look at addition then. So the first thing you're going to need to be able to do, if you're going to do any column addition, which we'll talk about soon, is you're going to need to be able to add your smaller numbers correctly. Things like 6 plus 7. Okay, there's lots of different ways you can do this, and you probably have a way. But if it doesn't work, you need to get this sorted out, otherwise you're not going to get any of your column methods right. So 6 plus 7, you can do this on a number line or a ruler. You can almost always take a ruler into tests. So if you learn to do it on a ruler, you should be fine. 6 plus 7, we're going to start on 6, but you don't count the number you start on. So we go 1, 2, 3, 4, 5, 6, 7, and the answer is 13. If you accidentally count the number you start on, it will go wrong. Let's look at another one. 9 plus 7. You go to 9. You need to count on 7. You don't count the one you start on. So you start counting when you get to 10 like this. 1, 2, 3, 4, 5, 6, 7. The answer is 16. There's many other ways of doing this. Some people would like to jump this up to a 10 and add 6 and they'll get 16. Many people will count on their fingers. You just need to have a way of getting this correct.
I'm definitely a fan of the if I'm doing this orally or in my head, I'm looking at the nearest next place value. So for 9 plus 7, I'm a very big fan of going, how many do I need to get to 10? I need 1, and that means I only have to add 6 more to make 16. That's how I do it. How I do it in my head if I got a question like this.
Absolutely, and it's the same for me as well. To be honest, we don't count on the ruler anymore.
Yeah.
But there's nothing wrong with counting on the ruler if that's what you need to do to get the answer right. Then you can start doing more mental methods, doing it in your head. As long as it's working, that's brilliant.
If you just write 6 plus 8 there, like a question like this is quite a good example because, you know, two maybe slightly larger single-digit numbers, it might be quite difficult to kind of grasp the number quickly enough. But when you break that 6 down into a 2, which will make 10, and a 4, which will make 14, it makes it that much quicker, at least for myself. If you can, yeah, you see.
So it is 14.
Yeah, it's 14. So if we're looking at writing this on the number line, we're going from 8 or from 6. It's fine. From 6, we're looking at that 4 numbers until we get to 10.
1, 2, 3.
So we've used 4 of the 8 numbers, so we only need to add another 4 more
3
to get to
4.
14. And of course you can do it like I did it earlier in my head, from the 8 to the 14, adding 6.
That's, especially with bigger numbers, it's often useful to start on the biggest number and go 8, 9, 10, 11, 12, 13, 14. So whichever way you do it, make sure you can do this.
Yeah.
If you have any trouble, ask your teachers. You need to get your counted on sorted before you'll be able to get column methods correct. Okay, when I teach addition, I like to talk about the 3 types of addition. This is just my own invention, but I do see it as 3 different types of column addition. So let's start off with the first type, which is whole numbers plus whole numbers. Normal numbers plus normal numbers. You've got to remember what you learned in previous years, which is to line whole numbers up down the right. So you don't line it up like this, do you, Mr. Blum? Because this is not lined up down the right.
And I see that happen a lot more than I want to see that happen. And it all comes from not understanding your place value. So like in our previous lessons, if you don't understand the place value of your numbers, adding is not going to be that comfortable for you.
Yeah.
So I would even say that if you were doing something like that, put your hats and caps in so that you consider that 9 should be a unit.
There we go. 4,238 plus 789. And we do, as Mr. Blum says, see a lot of children putting things in the wrong place in year 5 and year 6 all the time. So make sure you're not doing that. So we line up down the right. Should be a straight line down the right here when you're going to do addition, okay? 8 plus 9. Now, however you do this, whether you use your fingers, whether you use a number line, you need to be getting these right and work on it if you don't. 8 plus 9 is 17. 7 carried a 1, make sure it says 17, not 71. It says 17. Some people carry their little ones in a different place, like on top. Your teacher might tell you to carry it in a different place. It's okay, still works, as long as you know what you're doing.
Well, Mr. Saul and I are very similar maths teachers. I put mine on the top, he puts his on the bottom. The only thing that you need to know when it comes to carrying that is when you're carrying the 1, you're understanding that you're carrying a 10. When you're adding 3 plus 8, you're adding 30 plus 80. You're going to put it in the tens column, so there's not going to make much of a difference. But make sure you understand what you're moving across.
So 3 plus 8 plus 1, which is really 30 plus 80 plus 10.
Yes.
3 plus 8 plus 1 altogether is going to be 12. It's worth 120, but we write 1 carried a 2. 3 plus 8 plus 1 was 12, so make sure we've written 12. Then we have 2 hundreds plus 7 hundreds. 2 plus 7 is 9, plus 1 is 10. Make sure it says 10. And then 4 plus 1 is 5. Let's make sure our answer makes sense. Plus makes things bigger usually. Almost always plus makes things bigger. So 4,238, when you add 789 it goes up to 5,027. Make sure your answer's got bigger if you're doing a plus. A lot of times people will do the wrong sign. One of the most common mistakes, isn't it? Talking about common mistakes, first of all you've got to make sure you copy the question down right. I'll check. 4238 went 4238. 789 went 789. Common mistakes are copying the question down wrong, doing the wrong sign, and then just getting something like 8 plus 9 wrong. Check it's 17. 3 plus 8 is 11, plus 1 is 12. 2 plus 7 is 9, plus 1 is 10. 4 plus 1 is 5.
Another mistake that I see is that children, 1, forget to add the leftover amount, and 2, forget to even put it in there. So just make sure that you're very clear. So that 8 plus 9, if you don't add that leftover amount to the tens, it's going to be 8 plus 9 equals 7. And if I said to you 8 plus 9 equals 7, you'd say I'd be ridiculous, right? So make sure that you know that 8 plus 9 equals 17. So that 10 in 17 needs to be added in a different column.
So with addition, you will get it. After a bit of practice, you'll get it. But the mistake a lot of children make is they then think that they're never ever going to get it wrong. But really, once you know the method, the hardest thing is making sure you get it right every single time. Because we see mistake after mistake on addition. So never be too arrogant, never think you're too good at addition. Make sure you're very careful and make sure what you actually do is you get the question right every time. I'll do another whole number plus another whole number.
You can put your commas in if you wish.
3,000.
Separate the thousands and the hundreds.
Where do commas go?
In between the thousands and the hundreds to represent that there's a thousands value and then there's a units value with the units, tens and hundreds.
And we say commas go 3 from the end as well.
Yes, they're in groups of 3s. The numbers are always grouped in 3s.
Let's line this up down the right. You see down here is the right hand side. You don't have to draw these little dots of course, but I'm just showing you how it's lined up down the right.
Why couldn't the 74 be on the left hand side, Mr. Saul, next under the 3 and the 2?
If we did this 74, if I'd written over here,
yeah. Why couldn't you do that?
What you've actually done there, units, tens, hundreds and thousands, is we've put 7 in the thousands column, we've put 4 in the hundreds column. It's only 74, it's not 7,400.
So you're saying that if I put that 7 in the thousands column, that 3,285, which is a massive number, adding just a little bit, which is 74, I could give an answer of 10,000?
Because
that's how wrong. Yeah, that's how wrong you could be by doing that.
Let's go back to the correct position, which is 74 like this, lined up down the right. So we do our addition. 5 plus 4 is 9. Nothing to carry this time. 8 tens plus 7 tens, but we can do 8 plus 7 is 15. 5 carried a 1. Make sure it says 15, not 51. 15, the one in front of the 5, the one before the 5. 2 plus a little 1 is 3. And 3 at the front. Has this got bigger? 3,285 plus 74, 3,359. It has got bigger.
Not by much, but you know.
Yeah,
it shouldn't be by much because you're only adding 74.
So it hasn't even got, it went on to the next 100, didn't it? And over to the next 100. Next, let's look at whole numbers plus decimals. Okay, so you often have to add a whole number, like 546, to a decimal number. Say 3.72. Now this can be quite easy, and maybe some of you can see the answer in your head, but what I really want you to understand is how to line these numbers up. Okay, what I say when we have a whole number like this and a decimal number like this is things are going to be a bit tricky because only one of those numbers has a decimal point, and really they both need to have a decimal point. So what I would say about 546 is If there's no decimal point, where does it go, Mr. Blom?
After the unit.
And I always say at the end. If there's no decimal point, where does it go? At the end. And you do this every time you're adding a whole number to a decimal. If there's no decimal point, put one at the end. Then I'll normally put my decimal points in, because on addition, you always line up your decimal point. And this will tell you where to put your decimal point for the next number, because we have 3.72. The point's already in, so it's got to be 3.72. This looks weird, doesn't it? It's sticking out. Once you start working with decimals in addition, it's not lining up down the right anymore. What's actually happening is a decimal point is lining up. So, this is how you'll add these numbers. 546. Sometimes children like to place zeros, the placeholders in here, just so that it's all nicely blocked off. You don't actually have to do that on addition. So 0 plus 2 is 2. 0 plus 7 is 7. 6 plus 9 is 6 plus 3 is 9, I meant to say. 6 plus 3 is 9. Then we have a 4 and we have a 5. Let's check it got bigger. 546 point nothing plus 3.72. 549.72. Just a little bit bigger, but it did get bigger.
If you were to do this in your head and you're very, very good at place value, you could see that 546. I'm a very big fan of like splitting up your place value. So you got your 3 and you got your 7/10ths and you got your 200ths. Now, in the number 546, there aren't any decimal values. So the addition of the 72, 7 and the 2 decimal values are just going to be 7, 2. So 546, I'm literally only having to add 3, which should make 549. And then, as I've said, because 546 doesn't have any decimal values, I'm just adding the 7/10ths and the 200ths.
Let's do one more example of this. Not the hardest thing we'll ever come across in maths, but let's do one more. Let's have a whole number, 67, plus a decimal number, 5.4. Really just to check our lining up. So 67 doesn't have a decimal point, so where would I put one? At the end. So 67 point. Line up your points. Make sure in addition they're lined up. They go straight down every time in addition. 5.4, you know where it goes because the point has to go in the middle, so it has to be a 5 and a 4, 5.4. If you want to place a 0 on the 67 point, sometimes people like to do a little ghost 0 to show that they've placed it in themselves, or a normal 0 is fine. 0 plus 4, 4, 7 plus 5, 2, 6 plus 1, 7. 67 plus 5.4, it's like 67 plus 5 and a bit. 67 plus 5 is 72. So 67 plus 5 and a bit is 72 and a bit. 72.4. Let's move on to a decimal number plus a decimal number. Start off with something quite easy. This one could be money really. £3.85 plus £2.19. So when you've got decimals plus decimals, both numbers already have a decimal point on. So what you must make sure you do is you line up that decimal point. That's extremely important. But this is not too difficult because both numbers have 2 decimal places. 1, 2 and 1, 2. Both numbers have 2 decimal places. So it's going to line up quite nicely. 5 plus 9 is 14. 14. 8 plus 1 plus 1 is 10. 0 carried a 1, make sure it says 10. 3 plus 2 is 5 plus 1 is 6. £3.85 plus £2.19 went up to £6.04. It got bigger, didn't it, Mr. Blom? Okay. Let's do a slightly more difficult example next, where we don't have the same number of decimal places in both numbers. So something such as 5.3, and this is the kind of questions you're going to get in tests. They're going to be set up for you to get them wrong. 5.3 plus 3.842. Now a lot of children would line this question up wrong. Which number is biggest, by the way, Mr. Blom?
5.3.
Oh, it doesn't look biggest.
No, because it has more digits, yeah.
Yeah, 5.3 is 5 and a bit. 3.842 is 3 and a bit. So 5 and a bit is bigger than 3 and a bit. So if you line up your decimal point, you're going to line this up correctly because it's 5.3 and then it's 3.842. It sticks out. these trick questions, which are the kind you get in tests, they're going to stick out like this a lot of the time. They're not going to line up down the right. You can place your placeholders here if you want.
Yeah.
Dotted zeros or normal zeros.
Always find that helped a lot with lining up.
And to be honest,
if anything,
it's a very good idea to do this in addition, because in subtraction you have to do it. Anyway.
Yeah, exactly.
So we'll stick with addition for now. 0 plus 2 is 2. 0 plus 4 is 4. 3 plus 8 is 11. 1 carried a 1, make sure it says 11. 5 plus 3 is 8, plus 1 is 9. It got bigger when we did plus. We did do plus, didn't we? Just have a quick look at the question, make sure we copied it down right, and then maybe check our addition. We look fine, Mr. Blum?
Brilliant.
So
Larger number, yep.
Decimals plus decimals.
When adding numbers is also a useful way of utilizing a number line. Now, there are many ways in which you can use a number line, especially if you're like looking at differences in temperature. I suppose when we go into looking at subtraction, but also you can use a number line when you're adding numbers. And one of the things that is really useful in doing many things is partitioning numbers from their place value. So if I'm looking at this number 120 over here, I can partition this number into 100 and 20. As you can see, I'm separating them by their place values, and if I added 100 plus 20, it would make 120. Now when I'm using this number line, what I want to do is I want to add this 120, but I don't just want to add it in one whack. That would be quite challenging. I want to add them separately along this number line so that when I get to my final answer, I know that I've added that full amount. I start with the higher number. If I started with 120, I would have had to add far more numbers. So adding 120 is nice and simple. I only have to add 100. I only have to add 20 to it. And you can be really careful and conscious, and you don't have to go and add 20. You can add maybe smaller amounts such as a 10, like I'm going to do now. So as you know that 120 is made up of 120. What I'm going to do is, in case I'm not a confident adder, I'm going to add 10 to this 540, Mr. Saul. And what am I going to get? I'm going to get 550. Now, I always put what I've added to make sure I know. And once I've added 120 amount, I'll be happy. I'll now add another 10. And that makes 560. So now I have added that full 20 amount. What do I still have to add to this 560? Just 100. So what I'll do is I'll make a slightly bigger jump to show that it's, I'm adding a larger amount, and that would make 660. 100% made sure, just using a typical number line, and partitioning, which I love to do anyway. Next example, we've got 390 plus 233. Start with the larger number. Obviously, it's not too much of a difference between the two numbers, but 390 is the larger number. You could actually start with 233 because 390 does not have any unit values, but I'm going to go up with 233 because I'm a very comfortable partitioner, and I know that 233 consists of 200, it consists of 30, and it consists of 3, and I can add those separately. I'm actually going to add the 3 later on because I want to keep that unit to 0 for a while.
Partitioning is like smashing up a number into its parts, isn't it?
Yeah, smashing up a number, yeah. So I'm going to add the 30. I could add 3 10s, but I'm going to go a bit quicker now because I'm slightly higher level here, and I'm more confident doing this method. And 390 plus 30 would be, so plus a 10 would be 400, plus another 20 would be 420. I'd like to reiterate that you could add 10 every time until you get to 30, no problem. I'm going to get rid of that 30 there because I know that I've done, and now I've got 200. Maybe I'm going to be a bit more cautious with the 200, and I'm only going to add 100 twice just to make sure. So I've got 520, add another 100 again. I know it's a small jump. 620, and yes, I've only got one more thing to add, and that's the 3, which would make my number 623. Cancel it out to know that I've done everything. If I look back and check, have I added my 200? Yes. Have I added my 30? Yes.
Did it get bigger?
The number
Plus
definitely
makes
did get
things
bigger. Yeah, absolutely. The number did get bigger. And finally, you can even do it with slightly larger numbers, Mr. Saul. I'd be comfortable in doing these with larger numbers. I know we have the other method to do it, but it's always good to know what you're comfortable with. And we've got 7201 plus 2109. What is the larger number? 7201. I suppose let's use that as our base number. So I'm going to write 7201 down here, and then my job is to partition 2109. I have 2000s, I have 100, I have no 10s, which is quite good, so I don't have to add any 10s, and I've got 9 units. I see a connection here where I can add the 9 units pretty quickly. Can you see it? If I have a look at the unit over here, which is 1, and I have a look at the unit over here, which is 9, can you see something that might make this a good idea to go straight into adding the 9? Well, if you said that if I add that 1 to 9, you're absolutely right. The number bonds to 10 of 1 and 9 would make this really easy to make this 7210. That's pretty lucky, isn't it, Mr. Saw? And actually makes this method quite useful now, because I've only got to add 2000 and 100. Let's add 100 first. Add the 100. Very poorly written. And I get 7310. I've already added that 9. Naughty Mr. Vlom. There's no value in that, so I don't have to add that. And I've added the 100, which leaves me with adding 2000. 7,000, add 2,000. I think I can add that at once. What do you think? I think that might be easier to add it at once. So I'm going to add the 2,000 altogether. If you're not confident adding thousands, then I would recommend you going 1,000 by 1,000. But 7,310, and you add a 2,000 to that, you just have to change the thousands column, which would make it 9310. Is the number getting larger, as Mr. Saw always asks very, very well? Yes, it is a larger number. If I had to estimate 7201 plus 2109, I'd say it'd be around 9,000. So there you go. Just a quick one on the number line.